Okay. So why SURFER? So reservoir engineers really use a hell lot of softwares. Think of Petrel, Eclipse, numerical reservoir simulation, or think of petroleum experts, Prosper, or think of copper engineering, well testing software, and so on. So the list goes on. But one area is visualization in our practice, visualization. And why we need this visualization? Because the nature, you know, it's very complicated sometimes. And especially now when we are really swimming in this ocean of data because of this digital age, and so there is really a tsunami of data, and somehow we have to cope with it, right? So somehow we have to see it, somehow we have to understand it, and human beings and the human nature and the human brain is very visual oriented, so we understand visuals, pictures much better than just a bunch of sort of whole ocean of data or numbers, right? So that's why it is very true when we say, okay, one picture is worth more than 1,000 words, okay? So SURFER is one of the softwares which helps us to understand a lot of data. Okay, so just a few words about the developer of SURFER. SURFER was developed by Golden Software Company. This is a company based in Denver, Colorado. There is a famous institution over there. It's a famous, well-known university called Colorado Schools of Mines. And 3 graduates in the early 80s, when the first personal computers appeared and came to the market, the famous IBM PC, they soon realized that there will be a huge demand for reservoir software, not reservoir software, but visualization software. So geoscientists, mining engineers will need certainly some tools which can help in their work, right? So they immediately realized this. So when they graduated after the university, they founded Golden Software, and this company became then very successful. First of all, because they were the first on the market, right? And the second one, they make really gorgeous software, very nice, very easy to use, very simple to learn, very nice user interface. Plus, they kept the price reasonable, so many engineers and geoscientists could afford it to buy it, right? So that's why they really became a good company, a successful company. And now let me show you their website. I encourage you. Can you see the website? Can you see the website? Can you see? I've turned off now. Just a second. Share. Yes, this is this one now. Just a second. So this is their website, okay? Golden Software. I encourage you to visit this. You can find a lot of information over there. You can see that they have more than 250,000 users and so on, lots of success stories, a huge gallery of stories and so on. So this is the company's website, okay? So I encourage you to visit this website. Okay, so let's go back to my screen. And they became also successful because during the times or during the years, they have also extended their product line with other softwares. For example, Digir and Voxler, we will have a few words about them also in this presentation. And so, yes. Okay, so let's go to the next slide. What is SURFER is based on, how SURFER actually works, right? So you know from mathematics, if you have a function of 2 variables and you can express the third variable, the third coordinate with as a function of x, y variables, then this can be represented as a surface, right? So probably this is the origin of the surface of SURFER's name, right? SURFER. For example, here on the right side, you can see there is a pressure surface. It's a pressure distribution within a small reservoir. You can see these 2 holes. These are the holes where the wells are producing. And this red area is a purely developed, poor quality reservoir area. So this is not releasing the pressure so quickly. So that's why the pressure is high here. So as you can see, with a simple picture, we can really understand the situation in the reservoir. So that's why this is a cool stuff. This SURFER is a very nice stuff. Okay, so how SURFER actually operates? You have to provide X, Y, Z data. Okay, and then SURFER makes a so-called grading. He takes his data, he reads them in, and then he makes a kind of interpolation. The default interpolation method of SURFER is called kriging. Craig was a mining engineer in South Africa, and then he developed an algorithm which, with the help of which he could make very nice mappings and distribution of minerals and so on, and gold and whatever. So this method became very popular, and many mapping softwares are using this so-called kriging method. And once this grading file has been generated by SURFER, then SURFER it uses to actually draw the picture, the 3D surfaces or the contour maps or whatever. So I interrupt once again my PowerPoint, and I would like to show you an example file. Just a second. I have to find my directory. Okay, so just a minute. Okay, here I would like to show you an example file, very simple. It's located in Excel. You just open it up, and then it starts up, and you can see 3 columns where nothing special: X, Y, Z coordinates, and then this is what SURFER actually reads in and makes the interpolation, and it makes the grading. Okay, now let's make a SURFER demo. I fire up now SURFER for us, and then we will see how it works actually. Okay. So this is SURFER when you can see this, the window?
Yes, sir, we can see.
Okay, wonderful. So this is now SURFER. It's a usual kind of Windows type of software. On the top, you can see the toolbars, right? On the left, upper left, you can see a window where SURFER will show you what kind of objects he's working with. And the window below, this is the property window. Here, whenever you select an object, let's say an axis or a surface or whatever, here you can adjust its properties, okay? Now, so let's start the process itself. So I click on grading, and I take the data, okay? So I take this example data file, and then a SURFER will open it up, okay? He makes some statistics. He will say, okay, this is X, Y, Z maximum, minimum values, and this will be the file where he writes the results. I just click on OK. I have the file already, but I will overwrite it. And then SURFER makes a run. He will make a little reporting. You can print it out, whatever. He makes here some statistics. You can save it. It's not very interesting. You can run it anytime. Okay. So now SURFER has generated the grading file, the grade file, and now I can move and take this grade file, and I can generate my first 3D map. Okay, so I open it up, as you see. Okay, and here it is. Very easy, very quick, and very informative. And now you can customize your plot in many different ways. You can turn it, for example. Oh, shoot. I have to find it. All right, button. Okay, you can turn it to any different kind of directions. Okay, so you can have, for example, this is the bottom axis. Then you can say, okay, I can give here a name. You can customize this. Okay, then he arrives. I can even rotate this axis. So a lot of things can be done in this way. Okay, I can take the numbers. I can rotate it. You can even add titles to it, whatever. So in many different ways, you can customize your plot. Now let's move to another one kind of plot. This will be a contour map. Okay, once again, I read this grading file in. I just click, and then he made this contour map. But I have to turn off no, not this one, but I have to turn off the 3D map so you can see it. Okay, so this is very easy. So when you really want to have some quick and dirty and visualize your data, then SURFER is an ideal choice because you can make it very quickly. Okay, so this is SURFER. Now let's close it for a while. No, and let's go back to our presentation. Okay, so the next one is scripting. This is a very cool feature of SURFER. You certainly all use Microsoft Excel, right? And Microsoft Excel has the so-called macro features where you can write little macros in the Visual Basic language. And then this makes Excel really, really powerful. You can do very, very complicated things within a short time. So this makes Excel a very powerful tool. And the language is Visual VBA, Visual Basic for Application. And this is an excellent tool for automate your tedious processes, because sometimes when you use SURFER or Excel, you have to click a lot of times to make an adjustment on your plot, right? So this might be very tedious and very time consuming. So you have the you desire to make it automatic. Okay, so how we use this now in underground gas storage, and I would like to say here a few words about our company and about actually underground gas storage. We are a Hungarian gas storage company. We are located in Central Europe. We are one of the largest Central European gas storage company. We have a capacity of about 4.4 billion cubic meter of gas. So the Hungarian national consumption is about 9 to 10 billion cubic meters a year. So nearly half of it is secured in gas storage reservoirs. So the gas supply in Hungary is very safe. Okay, we have about 200 wells in our, and this is our website. We will visit our website very soon, just a few words more. So actually why we need gas storage. The reason is because, as you see, this red line, this is the supply, and this blue line or green line is the consumption. So the supply is nearly permanent, right? So oil and gas companies like to produce permanently because this is good for their business. But the consumption is seasonal, right? So we need more gas in the winter time because it's cold, and we need less gas in the summertime because it's warm, right? So the task for underground gas storage is to balance this imbalance. Okay, that's the reason why gas storage exists. Actually, it was invented in the early 20th century. I think the first gas storage company was made in Canada. And after the success story of this one, it spread across the world. And now there are several hundred gas storage facilities over the world. And this is the reason, the difference between supply and consumption. Okay, so this is a very simple sketch of the route of the gas, how the gas is moving. The gas follows this red arrow. In summertime, we get the gas through these huge pipelines. Then they go through our compressors. The compressors increase the pressure of the gas, and then it is injected into the gas reservoir. And then in wintertime, this process is reversed, right? The gas starts to flow from the reservoir out back to the surface. In this case, the pressure is high, so it avoids the compressors. No more compressor is needed, and this is then given back to our customers. Okay, so just to make it some geographical clarifications, let me show you once again the net. Okay, so I have to go to this one. Okay, and now let's go to Hungary. So this is our country. You can see Hungary. You can see the map.
Yes, sir, it's visible.
Okay, okay. So this is Hungary. We are a Central European country here, nearly in the heart of Central Europe. Our gas storages are located on the eastern side of the country. There are here three reservoirs here. Three facilities are here on the east, and one reservoir is located here on the west. So the gas comes mostly from Russia. There's a huge pipeline here from the east to Hungary from Russia. There is also a northern pipeline coming from Slovakia to Hungary. This is also carrying some gas. And then two pipelines will put very soon on operation. One is coming from Romania, because the Romanians have found several significant gas resources here in the Black Sea, offshore Black Sea, and partly they want to use it, but some part will be exported. And there will be another one pipeline, which is called South Stream, right? And this South Stream carries gas from Russia. It crosses the Black Sea below the water. It arrives to Turkey, and from Turkey, it comes towards Hungary, and it will end up here close to Vienna. There's a huge gas distribution hub. This is called Baumgarten in Austria. So where lots of companies collecting the gas, and this is distributed among the customers. So Hungary can also take gas from Austria. And there is an interesting new development here, which is related to Croatia. Croatia is our southern neighbor, and Croatia has invested recently, in the recent years, heavily in LNG, liquefied natural gas. So they have built, I think, 5 LNG terminals along their shoreline, and one of them, which is located here on the Creek Island, this was now put on operation recently, a few weeks ago, maybe a month ago or so, and the first gas transportation has already arrived. The first ship has docked into this terminal, and then now Hungary will be able also to purchase gas, LNG gas, from this Croatian terminal. And there is a pipeline. This is called the Adriatic pipeline, and this is connecting this terminal with Hungary. So Hungary will be able to draw gas also from here. I think the first transportation came from Qatar, but I'm not sure. But you guys, it might be that one day we will buy gas from Algeria, LNG gas from Algeria, because as far as I know, you have plenty of gas reserves, and there is also a pipeline, I think. So. Yeah, anyway, so one day we might also buy gas from Algeria. Okay, plus you may also know that recently, in the recent years, significant gas reserves were found here in the Eastern Mediterranean, right? Think of, please, of the Zohr field from Egypt. It's a huge field. And then the Leviathan field from Israel. And there are several other ones here, which I don't know the name. Something is close to Cyprus. And these countries now think about that in the future they will team up and build a pipeline which will carry the surplus gas. So they will certainly have some domestic consumption, but then part of the gas will be transported to Europe, because Europe is here a huge market. We don't have so many gas, but we need gas. So that's why. So probably this this pipeline will also cross Hungary, but I don't know. This is the plan for the future. Okay, so this is the geographical situation. And now let's visit our website. I would encourage you also to visit our website. Here you can find a lot of information about our company. Here is an introductory video about gas storage and how gas storage works. Very nice. But the most important or most interesting part of this website is you can make a virtual tour in one of our storage sites. Okay, this is a bird's eye view of one of our storages. Now let me show you the way of the gas, how the gas comes into our storage site. This is this big pipeline I mentioned a few minutes ago. This is where gas transportation companies transporting the gas to our storage site, right? And this is also the place where the gas leaves our, in the wintertime, our stored gas leaves to go to the national grid and to the customers. So many things are here, lots of surface facilities, chillers and ventilation and ventilators to cool down the gas. The most important is, let me show you the compressors. We have two buildings of compressors. This is a latest one, this is a new one because this gas storage facility went through an extension a few years ago. Okay, so the capacity of the storage size was increased, and that's why a new compressor building was built, and in the two were compressors, and these are the motors which drives them. So we have several thousands of horsepower for compressing storage to put the gas into the reservoir. Okay, so this is the Siemens compressor, what I have shown to you. And this one, these are the old compressors. These are piston compressors driven by electrical motors. The yellow one is the compressor itself, and the blue one are the compressors, right? And the whole facility is operated by electricity. So we consume a lot of electricity. Now let's go back to, once again. Here you can see the gas processing units. These are for purifying the gas, screening out any kind of impurity like solid particles, whatever, and moisture, whatever, because there are very strict regulations how the gas can enter the reservoir and how the gas can enter the national grid transportation pipeline. And that's why we have to purify the gas heavily. So this is done here with these separators. Here is the transformation station, which is at the edge of our storage site. As I mentioned, we are using electricity to drive the compressors. So this is the transformation which transforms the high voltage electricity to low voltage in order to be able to drive the compressor electrical engines. You can see these are these high voltage electrical lines in the neighborhood of our storage facility. And then what I would like to show you, and this is the gathering line, this large horizontal line, and these individual lines which are perpendicular to this one, these are the tying in lines. These are the lines which tie in the wells directly to our facilities, to our gathering lines. And here in these lines, there are a lot of sensors. We measure a lot of things. We measure pressure, temperature, flow rate, whatever. And each of the wells can be regulated or controlled individually. This is the old gathering system. And here, this one is a new one, because as I mentioned, the storage site a few years ago was extended. So we have drilled a few new wells, and these are the tying in lines of these new wells. This is the entrance to the storage site, and here's the control room. Here are the guys controlling the whole system and checking what's going on, and if there is something wrong, then they can immediately interact. And so it's very, very modern one, and we like it really, so we love it. Okay, and the wells are located around this storage site. The outside of the storage site here, we have some forests surrounding this storage, and the wells are located in this forest, and the lines are buried into the ground. The connection lines are buried into the ground, and they run to the wells. Okay, now so let's come back to SURFER, how this is connected to SURFER, and let's go back to my PowerPoint. Just a second, I have to share the screen once again. Okay, this is this one. So as I mentioned, this is our next slide. As you can see from the storage history, how the storage goes, we have 2 times a year a shut-in period. This is one is in springtime and the other one is in autumn time, and this is about 10 days or 2 weeks or something like this. And what we do during this period, then we upgrade our numerical models, we make static pressure measurements, we make inventory, we make reports, we summarize up the experiences which were gained in the previous cycles, and then we collect it, we make a little reporting, we discuss it with the storage side personnel. So there's a stronger communication between the reservoir group and the storage technical staff. And yes, this is what we use it for this is in springtime and autumn time, and this is the time where the reservoir switches from injection or consumption to injection or vice versa and so on. Okay, so here you can see that, as I said, thousands of sensors are spread across or located across the whole surface facilities. We measure wellhead pressures, we measure temperatures, we measure compressor inlet pressures, outlet pressures, and so on. We measure gas rates, whatever. So a lot of information, and this is done by the so-called plant information system. This is made by Oshisoft. It's a software company, and once we have all these data, we have the pressure data, then we are using vertical lift performance curves, VLP curves, which help us to determine the reservoir pressure from surface measurements. So we can save a lot of money because we don't have to measure it directly by static pressure measurement, but we are able to use VLP, vertical lift performance curves, and then we can calculate the bottom hole pressure, we can calculate the reservoir pressure, and then we can make nice plots of them. How this whole system works, all the sensors are collecting these data, right? And this everything goes into a huge database, which is heavily growing, yes, because these sensors generate gigabytes of information or digital data, and this all goes into a huge database. And then most of us have access to this database. It's sold very easily, because in our Excel spreadsheets, we have a plugin, and then we can activate this plugin, and this can download information from this. Everybody can have access to it, and this makes it very, very efficient. So everybody can see the current situation in the whole storage system. Okay, so now let's go to SURFER scripter. Once again, I fire up now the scripter, and I have to share my screen once again with you. Yes, it's this one. Okay, so I started scripter. Scripter is actually, as I said, very similar to Microsoft Excel macros. This is this IDE, this is the interactive development environment. And then here you can write your code, and then here you can run your code. Okay, so I have prepared for your code here. I just love to, you can see it, right? Okay, so here's the language. Here is this example code. I have written it to process all the data what we collect, as I mentioned in the previous slide. We collect a lot of data, and then we would like to have distributions, pressure distributions in the reservoir and so on. So it's fairly long and fairly complicated, but you can very easily standardize or automate some of the stuff you have to do with SURFER. So it's a really powerful feature of SURFER. Now it's enough to show it. You can even make for yourself a graphical user interface. Okay, I can show it to you. Yes, so this is just like in Excel. You can open up a form, you can place controls on it, command buttons, combo boxes, check boxes, command bars, and so on. So it's really very powerful. You can make it very easy to use, so everybody can use it in the company once you have it ready. Okay. So now let's see how it works. I started here with this small green arrow. Okay. So he fires up. Just a second. I close this one because SURFER. Okay, so SURFER has been started here in the background. Maybe you don't see it, but it's a little bit difficult to share all the screens. Let's try it. This is now SURFER, but now you can see SURFER. Okay, but you don't see the macro. Anyway, so I start the macro, and then he will fire up, and then I take the sample data file, what I would like to show it to you, and then I click OK, and then I can select what kind of distributions I would like to have. I can have a 3D surface plot, and then I click on draw, and then he will make everything automatically ready for us. Okay, and voila, this is the result. So you can see lots of complicated stuff can be done just with a few clicks. What we see here is this is a precious surface.
Sir,
right?
sorry, sir. We are not seeing what you are doing. I think that your screen is stuck in one page.
Just a second.
Thank you.
Okay, it's here. So you see it now?
Yeah, perfect. Thank you.
Oh, sorry about this. I have to switch back and forth between several windows, so that's why a little confusion here. But now you can see this 3D surface, right?
Yes, sir. We are seeing.
Okay, you can see. So this is a snapshot from the reservoir. This is the reservoir pressure at this date, right? So some of the wells are injecting or injecting a little bit more, the other ones are less, so that's why there's a little bit bump in the surface. But anyways, we can have a good impression of what's going on. And you can see these streamlines here, these gradient lines, they show where in which direction the gas now is flowing between the wells. You also can see the contour lines, right? So quite a lot of things can be done. And now I also would like to, once again, I turn this off. I would like to show you how other things I can do with it. Okay, I can, for example, make, just a minute, I can make contour lines. Just a second, wait for it. Contour plots, draw. Anyway. Oh, I have to restart it again, sorry. Okay, so here is here is the scripter. Now I open up the scripter file. Okay, and I run it. Okay, here the menu comes up. I open up the file, and then I select what kind of pressure distributions I would like to have. I will make a contour map and I will draw it. Okay, and now I close this window, and I will go back to you. Hello. Are you back?
Sir, we can't see the screen.
Yeah, because something has happened. It interrupted.
Okay.
Just a second. It was interrupted. Zoom says me that it was interrupted. Just a second. It will come up. It seems.
Yes, sir. No problem.
I don't see the menu on Zoom. Okay, now I have it. Just a second. Okay, now you see it. Sorry about that. Yeah, here you are. So we can also generate these contour maps, right? So what you have seen in the previous slide, these were 3D distribution maps, but you can have the same also here in as contour lines, okay? So I really encourage you, if you like SURFER, you have to just dive in and you just practice. The help is very useful, very useful. A lot of information is there. So you can certainly find a lot of information on YouTube or whatever. Also the website of Golden Software. So just you have to make it, you just have to dive in and work and yeah, practice. Okay, so this is now SURFER. I close now SURFER and I go back to my presentation. Okay, so actually this concludes the presentation of SURFER, but I would like to have one word on SURFER. So SURFER is a really cool software, as you have seen. We are using actually version 11. Why? Because at the latest version is version 16, but we are happy with version 11 because for our purposes, for little visualization, that's enough, okay? But at the same time, Reservoir engineers need a lot of other things to do and calculate a lot. So that's why we are still sticking with version 11. That's enough for us. And we use other softwares to make mathematics and calculations and so on. So that's why we have not upgraded actually SURFER to SURFER 16. Okay, now let's come to another one software which is very interesting also. This is also developed by Golden Software. This is called Digir. So, you know, in our industry, the lifespan of reservoirs or oil companies is sometimes many decades long, right? So in previous and early information about these reservoirs are mostly in paper format, right? And this is very awkward and this is very inconvenient. And sometimes you may want to take these old type of information and you want to make it digitization, right? So you want to transform it into the digital space. And here is where Digir is a very nice piece of tool. This is also done by Golden Software. And as you can see here on the slide, Digir is not existing anymore as a standalone software because Golden Software has merged it together with version 16. So all the capabilities of what you will see here now, this is now inside ISurfer 16, version 16. Okay, so once again, now let's go to Digir. Just a second, it's here. And I have to share my screen once again. Okay, this is Digir. So the arrangement is very similar to what you have seen in the SURFER, but this is a little bit different. So let me show you an application. Here is, for example, an old top structure map of a reservoir, right? And here you can see this pink line. I could make a digitization of this contour line, and then you can export it. And then you can make a lot of things here. For example, let me show you how you can digitize points. Very simple. You go here, auto increment. I put the incrementation, let's say the limit to up to 200. Okay. I take a sign which I would like to use, and I switch to red. And then I can make here digitization, right? You can see here I can select points, and this is the way how it goes. You can select polygons, whatever. So it's very, once again, it's a very useful and very flexible software, and this is really easy to use. And here at the bottom of the screen, the SURFER is collecting the structures, the object, what he was taking from this structure map, and then you can export it. You can click on this red icon here, export, and then he offers you several different ways how you can export it, and then you can use it in any type of third-party software, Excel, MATLAB, or whatever, as you like. Okay, so this is Digir. I don't save it. Okay. Okay, once again. And now I would like to go back to my presentation once again. Share the screen. Okay. So the next one is what I would like to show you. This was the demonstration. This is Voxler. This is what I like really. It's very, very impressive. You will see it. This is a software made really for 3D distributions, surfaces, wells, whatever, any kind of distributions within in 3D space. So this is really, really powerful. And now I would like to fire up SURFER, just a second, not SURFER, Voxler. Okay. Just a second, guys. I have to switch all the time back and forth. But okay, it's here. This is Voxler, and now I would like to share the screen with you with Voxler. Okay, you see my screen? Hello.
Yes, sir.
Okay, so this is the reservoir what we visited on our website, where we made this virtual tour. But this is a bird's eye view from the space, from the top of the reservoir. Here you can see the storage site, what I was explaining to you. Okay, here's the transformation. Here are the compressors, whatever, and here are the wells spread across around this storage site. And now the magic will happen. Fasten your seatbelts. Everybody's ready for the magic. Okay, and this is the magic. So you can use Voxler to represent your distributions, everything, wells, whatever. And this reddish area here in the middle, this is the gas, how it looks like in the reservoir itself. Okay, so you can view your data in very different ways. For example, these are the perforations. I can show you here. We have some horizontal wells also here in this reservoir. It's a little bit choppy because of zoom, I think that's why. Here we have horizontal wells in the reservoir. So you can see anything from your reservoir, how it looks like, how the gas is located in the subsurface and so on. So it's very, very visible. Once you have to share it with your management, right, or you have to make reports and whatever, it's very easy way to do it. And Voxler will help you a lot to demonstrate where is the gas. Okay. And finally, I close it now. Finally, I would like to show you an interesting thing. Let's go back to my presentation. This is my presentation. Okay, so this is an interesting application what we have done with Voxler. Hopefully it will run. Oh, maybe. Okay, guys, you have to wait a few seconds because PowerPoint wants to upgrade this animation, and this will take a few seconds. Anyway, so you will see here in this little video what we have generated by the help of Voxler, how the gas storage process is actually taking place on the ground. Let me see whether I can start it. Just a few seconds. You can see my screen?
Yes, sir, it's visible.
Okay. So it will take a few more seconds. I hope I can show it to you. Okay, I think so. Yes. So you can see we have generated this animation with the help of Eclipse, Voxler, whatever. So this is the way how the gas is pulsating. You can see here several years of several cycles of gas storage, right? And this is how the gas is taking place or occupying the pore volume in the reservoir. And this is how it pulsates. When it extends, then this is injection period, which is summertime. And when it contracts, then this is wintertime, and we give the gas back to our customers. Okay, so this is, so you can see these softwares are very powerful, and you can really make a lot of nice things with them. So it's really a great help for reservoir engineers. Okay. So guys, this was my last slide on SURFER, Digir, and Voxler. And just one slide about me. You know my name. I'm really passionate about my profession in reservoir engineering. As I said at the very beginning, I think it's a very wonderful profession. I like STEM. I'm very technically oriented. I like coding and so on, softwares and modern ages, problem solving, innovation. This is a good place in reservoir engineering. You can follow your passion here. You can do all this stuff here. And my personal preferences are like biking, travel, music, drive, and pets, and so on. So hopefully you liked this presentation. And if you have some questions, I would be glad to answer if you have some ones. And yeah, thank you very much for inviting me.
Okay, thank you, sir. Actually, it was a really nice presentation. We have benefited a lot. We had a lot of information about the different golden software. Actually, we have a lot of questions. We'll pick some of them.
Okay.
Okay, the first one is, which language does the SURFER script use?
Beg your pardon once again, Abdulkader, could you repeat this? Which?
Language, programming language does the SURFER script work with?
This is also Visual Basic for Application, VBA. They are practically the same. Okay, so once if you know how to code in Excel, how to make Excel macros, then you can immediately use your knowledge here in Scripter. They are practically the same. They are practically the same, nearly the same commands, nearly the same instructions. So, yeah. So once you know Excel, you know SURFER, Scripter.
Okay, thank you. The second question is, for which purpose we use SURFER in reservoir simulation?
We are not using it for reservoir simulation. Because Petrel is very intelligent. Petrel himself can generate 3D pictures. We are using it just for quick and dirty visualization and reporting to the management. Okay, so reporting to technical staff. It would be way more difficult to carry with us Petrel and Eclipse and show them. It's too complicated for the technical guys, to our colleagues. So better we use it for demonstration and reporting. So we are not using it actually for a reservoir simulation. We just use it for visualization. Okay.
Okay, thank you. The next one is, does the last update of SURFER provides the option of implementing algorithms directly from Python?
I don't know, because we don't have a version 16, so you have to really consult the website of Golden Software, or they have a very nice support, and you can ask them. I don't know whether SURFER understands Python. Would be nice. But what I know, as I demonstrated to you, it understands Visual Basic, right? So I don't know actually, but you have to ask the support. Maybe there is a blog where customers are asking questions, and so you can log on, you can register into this website where there's a SURFER community, and you can ask the question there. Okay.
Okay, thank you. The last question is, what are the criteria of storing natural gas in reservoirs?
Yeah, first of all, the pore volume has to be enough. It should be not small, it should be not too big. So it takes a careful design, right? So what we are using depleted gas reservoirs. So mostly the gas was produced from the reservoirs, and then towards the end of the life of the reservoirs, a decision was made, okay, let's now turn these reservoirs to underground gas storages. But prior to turning them to underground gas storage, we had a very fair knowledge about how this reservoir are working. We had a lot of material balance analysis, we have a lot of numerical simulation analysis and so on. So we were very in a clear picture what the reservoir can be used for, okay? And yeah, of course, it is not bad if you have good permeability, right? Because you don't want to fight with your reservoir to give back your gas. So it's a good thing if it has enough veracity, and yeah, it should be not also too deep and so on. So it is a complex procedure to decide how to turn an underground a gas reservoir, a depleted gas reservoir, into a storage site. So this is the job of the reservoir engineers. So it was a careful planning before these depleted fields were converted to storages. This will be your task. This will be your work. Whenever you are working with the companies, this will be your work to decide, make simulations, check it out.
Okay, thank you again, sir, for today's presentation. I'm sure that our audience has really enjoyed assisting to you, and wish you the best of luck and have a good day. Thank you.
Okay, thank you very much for inviting me. All the best for you. Take care of yourselves and all that best wishes, right? And dream big, pursue your dreams, and yes, a lot of success for your professional life and private life. Okay.
Thank you, sir.
Okay, thank you very much. Bye.